When we look up at the night sky, we aren't just seeing stars, we're seeing history. Every beam of starlight is a messenger from the past, traveling for thousands, millions, or even billions of years before reaching us. Some of those stars may already be gone, but their light lives on. For centuries, humanity believed the universe was eternal, infinite, and unchanging. But in the 20th century, scientists uncovered a shocking truth. The universe had a beginning. That beginning, known as the Big Bang, wasn't just an explosion of matter. It was the birth of time, space, and energy itself. But what exactly happened during this unimaginable event? And how do we know? To answer that, we must travel back to the very first instant, 13.8 billion years ago. Before the Big Bang, what existed? This is one of the greatest mysteries in science. The truth is, time itself began with the Big Bang. Asking what came before is like asking what's north of the North Pole. It may not even make sense. Some theories suggest the universe was born from a quantum fluctuation, a sudden burst of energy from a sea of nothingness. Others suggest a cyclical universe endlessly expanding and collapsing, but at present we cannot know. The Big Bang is where our mathematics stops. Beyond that is mystery. Now let's return to the very first instant, t=0. The universe began as a singularity, infinitely hot, infinitely dense. Then, it expanded. Not slowly, but at a speed beyond imagination. In less than a trillionth of a second, the universe inflated faster than the speed of light. Space itself stretched like a balloon, growing unimaginably large in an instant. This period, called cosmic inflation, was crucial. Tiny quantum fluctuations, ripples in energy, were stretched to cosmic scales. These ripples would later form galaxies, stars, and planets. In the first 3 minutes, the universe was a boiling soup of particles: protons, neutrons, electrons, and photons. As it cooled, protons and neutrons fused into the first nuclei: hydrogen, helium, and a trace of lithium. This process is called Big Bang nucleosynthesis. At this time, the universe was still opaque. Photons constantly collided with free electrons unable to travel freely. These were the building blocks of all matter. Heavier elements like carbon and iron would only come later inside stars. Imagine a foggy room glowing with light but too dense to see through. About 380,000 years later, the fog lifted. The universe cooled enough for electrons to combine with nuclei, forming neutral atoms. Light was finally free to travel. This light still exists today, stretched into microwaves by the expansion of space. It's called the cosmic microwave background, or CMB. Discovered by accident in 1965, it's the faint afterglow of creation. The CMB is nearly uniform in all directions, with tiny ripples. These ripples are the seeds of galaxies. These ripples are the seeds of galaxies. The faint afterglow of creation helps us read the universe's infancy. After hundreds of millions of years, gravity pulled hydrogen and helium together into the first stars. These stars were massive, burning bright and fast, exploding as supernovae. In their cores, heavier elements were forged. Galaxies began clustering together, forming the vast cosmic web we see today. Without these stars, there would be no carbon, no oxygen, no Earth, no life. In 1929, Edwin Hubble discovered galaxies are moving away from us. The farther they are, the faster they recede. This was proof the universe is expanding. If we reverse the process, everything was once together. Evidence for the Big Bang. The universe isn't just expanding, space itself is stretching. The Big Bang is supported by strong evidence: the expansion of the universe, observed by Hubble; the cosmic microwave background, the afterglow of creation; the abundance of light elements, matching predictions; the large-scale structure of galaxies, seeded by early fluctuations. Together they form a compelling case. The Big Bang is not a guess, it's the best explanation we have. What about before the Big Bang? Some theories suggest our universe is just one bubble in a vast multiverse. Others propose endless cycles of expansion and collapse. Right now, our physics cannot penetrate the singularity. Perhaps one day a new theory of quantum gravity will. What does the future hold? There are 3 possibilities: heat death. The universe expands forever, stars die, everything fades. Big crunch expansion reverses, universe collapses. Big rip dark energy tears the universe apart. Current evidence points to heat death, an endless expansion into darkness. The future is vast, slow, and full of questions. The Big Bang is more than a theory. It's the story of how the universe, stars, and life itself came to be. Every atom in your body was forged in a star. We are, quite literally, the universe made conscious. The Big Bang wasn't the end of something. It was the beginning of everything. From a singularity to billions of galaxies, the journey is staggering, and it's still unfolding.